There is a hunter in the shallows, a ghost made of keratin and muscle. It has been waiting there, motionless, for perhaps 4 hours. Its heart beats only 2 or 3 times per minute. But you wouldn't know it, because the only thing visible above the tannin-stained water is a pair of nostrils and 2 eyes. This is not a dinosaur. It is something arguably more terrifying. A dinosaur went extinct because the world changed. This animal watched the dinosaurs die, and then it decided to simply refuse to follow the rules of biology. This is the true story of Crocodilus porosus, the saltwater crocodile, the ultimate marine reptile, the apex of ambush. We think we know the croc. We see the meme of the derpy lizard floating in a zoo pond. We underestimate it. Do not underestimate this animal. Because to understand the saltwater croc is to understand that evolution stopped trying to make a smart predator. It made a perfect one.
Let's start with the heart. Human engineers spend billions trying to create engines that can switch between high-octane performance and idle fuel efficiency. The saltwater crocodile solved this problem 200 million years ago. Like birds and mammals, crocs have a 4-chambered heart. But they have a secret weapon, the foramen of Panizza. It's a small hole between the left and right aorta. When the croc is basking on a sandbar, digesting a wild boar in the sun, it uses this hole to shunt deoxygenated blood back into the body, bypassing the lungs. It's a biological bypass valve. But here is where the insane part begins. When this animal decides to hunt, when it submerges to crush the skull of a bull shark, it slams that valve shut. Oxygenated blood surges to the brain and the tail. Its metabolism shifts. And suddenly, the log comes alive. Look at the lungs. Unlike our lungs, which collapse under pressure, a croc's lungs are rigid, anchored to the liver and pelvis. This allows them to drop their diaphragm, pull air back, and shift their center of gravity.
Watch that dive. No splash, no tilt. They descend like a submarine. They can hold their breath for up to 6 hours when resting. 6 hours! But when they are stressed, when they are fighting a Komodo dragon or another bull croc, their blood chemistry changes. They dump bicarbonate ions to neutralize the lactic acid buildup that would kill a human athlete. A human sprinter runs 400 meters, collapses, and vomits from lactic acid. A saltwater croc can wrestle a water buffalo underwater for 40 minutes, and when it surfaces, its blood pH is nearly normal. It does not fatigue. It does not cramp. It is the perpetual motion machine of violence. The skull. Let's talk about the skull. For decades, we measured bite force in pounds per square inch. A lion has about 650. A great white shark has about 1,500. A human has about 160, if you really have to bite a leather strap. Crocodilus porosus was measured in a controlled setting at 3,700 psi. But that's just the number. The biology behind it is horrifying. The jaw muscles of a saltwater croc are located behind the eyes, in massive, bulging pockets of tendon. When the jaw closes, those muscles pull upward on the lower jaw, like a block and tackle. But here is the tragic, hilarious, and terrifying twist. The muscles that open the jaw are weak. You can hold a large croc's mouth shut with a rubber band or a roll of duct tape.
That is not a weakness. That is a design feature. Once that mouth closes, there is no force in the natural world that can open it, except a pry bar or another croc. The teeth are not designed for chewing. They are conical, hollow, and self-sharpening. When a tooth breaks, and they break often, a new one is already growing inside the hollow cavity. A single croc will go through 3,000 to 5,000 teeth in a lifetime. But the true terror is the bite pressure. At 3,700 psi, bone doesn't break, bone flows. It becomes a liquid. When a large salty grabs a turtle, the shell doesn't crack, it implodes. When it grabs a human femur, the marrow is injected into the bloodstream instantly. Death comes not from blood loss, but from hydraulic shock. They don't kill you, they cancel you. But the jaw is useless if you can't find the target. And in the murky estuaries of northern Australia and Southeast Asia, visibility is often zero. It's just brown soup. So nature gave the crocodile a sixth sense. Look at those tiny black dots on their scales. They are called integumentary sensory organs, ISOs. In humans, we have touch receptors only in our fingertips and lips. A croc has these receptors on every scale of its body.
These domed pressure sensors are so sensitive that they can detect a single drop of water landing on the surface of a pond from 10 meters away. They can feel the wake of a fish swimming past its tail. But the ISOs have a party trick. They can detect changes in water salinity and pH. The croc knows just by floating whether it is in freshwater, brackish water, or open ocean. It knows the chemistry of the tide. Watch this behavior. The driftwood posture. The croc holds its mouth slightly agape, not yawning, but hydroplaning. The water flows through the mouth. The ISOs on the tongue? Yes, the tongue has them too. Feel the turbulence. If a fish swims into that dark cavern, thinking it's a cave, the jaw fires in 50 milliseconds. That is faster than a rattlesnake strike. That is faster than your visual cortex can process the image of the fish entering the mouth. From the fish's perspective, it was alive inside a dark hole, and then it was in the crocodile's stomach. There was no in-between.
Most reptiles are slaves to land. They have to stay near fresh water to drink, to bathe, to regulate their salts. The saltwater crocodile laughed at that rule. How? You would think drinking salt water would dehydrate a reptile. It causes kidney failure in iguanas. But porosis has a trick, stolen from sea turtles and marine birds. They have lingual salt glands. These are specialized glands on the tongue that excrete concentrated sodium chloride, salt, directly onto the surface of the tongue. You've seen the video. It looks like they are crying or sneezing salt crystals. That isn't crying. That is a desalination plant. When a saltwater croc spends weeks in the open ocean, and they do, we have tracked them traveling 500 miles across the Torres Strait, they are actively drinking the seawater. They absorb the water, filter the salt into their blood, and then pump that salt out through their tongue. This allows them to surf the currents. They use the tides like human commuters use a subway system. One tagged croc in Australia traveled from the Norman River to the Gulf of Carpentaria, then hugged the coast for 800 kilometers, hunting sharks in the mangroves, and never drank a single drop of rainwater. It is the only reptile on Earth that can do this for extended periods. That is why you find them on remote Pacific islands. That is why they swam past New Zealand. They are not lost. They are cruising.
We need to go inside, to the stomach. The pH of a human stomach is about 1.5 to 2.0, acidic enough to dissolve metal over time. The pH of a saltwater crocodile's stomach is below 1.0. That is battery acid. That is industrial-grade hydrochloric acid. Why? Because crocodiles swallow their prey whole or in large chunks. They don't have molars to grind. So the stomach has to do the chewing. A wild boar hoof, a turtle shell, a bull shark spine. It all goes into the acid bath. Within 48 hours, all that remains is hair, claws, and a pile of calcium sludge. But here is the weird part. Gastroliths. Crocs swallow rocks. Heavy, dense river stones. For decades, we thought they did this for ballast, to help them dive. That might be a side effect. The new theory is that these rocks act like a cement mixer inside the stomach.
When the muscular stomach contracts, the rocks bash against the bones and hooves, mechanically breaking them down so the acid can get to the marrow. They are literally making rock soup inside their bodies. And here is the terrifying truth. A starved croc will digest the rocks themselves. It will leach the minerals from the stones to survive. It is the ultimate recycler.
We call them reptilian brains as an insult, but neuroscience disagrees. The saltwater crocodile is highly intelligent. Not mammalian intelligence, not empathy or tool use, but computational intelligence. They learn. They remember. If a croc sees a fisherman in a yellow kayak and that fisherman shoots at it with a rifle, that croc will hate yellow kayaks for the rest of its 70-year life. It will attack yellow kayaks on sight, but ignore red boats. That is pattern recognition. That is associative memory. And then there is the talking. Bellowing isn't just noise. It is infrasound. The frequency is so low that humans can't hear the actual note. We just feel a vibration in our chest. These infrasonic calls can travel for kilometers through dense mangroves. They communicate territory, size, and mood. But the most chilling sound is the hatchling call. Before they even break the egg, the babies chirp. A high-frequency peep. That peep tells the mother to excavate the nest. It tells the father to guard. And if you listen closely, you can hear the distress call change. A baby croc taken by an eagle screams at a frequency that causes every adult croc in the pool to instantly swim toward the surface. They have a gang signal, and the signal means death to the flying thing.
They are born the size of a pencil, a predator snack. Birds, fish, even dragonflies will eat a hatchling. Their mortality rate in the first year is 99%. But here is the biological cheat code. Indeterminate growth. Unlike humans, who have a stop signal for growth, a croc never stops. It just slows down. For the first 10 years, they grow rapidly, about a foot a year, fueled by insects, frogs, and fish. Once they hit 4 meters, the growth slows, but it never ceases. A 50-year-old bull croc is not old, it is optimized. He has been eating a wild boar a week for 40 years. His jaw muscles have calcified into bone. His armor scutes, the bony plates on his back, have fused into a literal shield. You can estimate a croc's age by the wear on its teeth, but you can't reliably age them because they don't decay. They don't suffer from senescence the way we do. Crocodiles do not age in the mammalian sense. They die because they starve, or because they lose a fight with a bigger croc, or because a boat propeller hits them. If you put a saltwater croc in a perfect zoo with unlimited food and no rivals, biologists are not sure how long it would live. Possibly 120 years, possibly more. They don't die of old age. They just run out of world.
We call them living fossils. That's a misnomer. They aren't fossils. They are current models. The ancestors of Crocodilus porosus survived the end Permian extinction. They survived the Triassic-Jurassic extinction. They survived the KT event that wiped out the non-avian dinosaurs. How? Because when the asteroid hit and the sky darkened for a decade, photosynthesis stopped. Plants died. Herbivores died. T-Rex starved. But a saltwater croc can eat rotting meat. It can eat carrion that would poison a vulture. It can go 2 years without eating. Not hibernating, aware, but fasting, burning glycogen stores in its tail. When the sun returned, the world was empty, and the croc was still there. Today, they patrol the same estuaries that the first mammals feared. They swim under bridges that hold cars. They watch us through the same eyes that watched the first hominids drink from the river. We think we are the apex of evolution because we have iPhones and rockets. But an animal doesn't need a rocket to be perfect. It needs to breathe while holding a drowning horse in its jaws. It needs to travel an ocean without a map. It needs to turn bone into liquid.
The saltwater crocodile is not a monster. Monsters are born from fear. The croc is older than fear. It is the baseline. It is the final argument of the natural world. When you look into the water and you see those two eyes staring back, you are not looking at an animal. You are looking at a biological mandate that has never been repealed.